Today's screencast is going to talk about angles. An angle is formed when two rays share an endpoint. So I've got my first ray here, I've got a second ray here, and they come together at this common point. I'm going to call that A. So we're going to call our two rays ray AC and ray AB. That endpoint that they share is actually called the vertex. So angles have vertices. The vertex in this case is vertex A. It's a point. And we can name angles in one of a variety of ways. We can call this angle angle A. So we can name angles by their vertex. Sometimes there'll be a number in here, like number 1. We can also refer to the same angle as angle 1. Or we can refer to the angle by using 3 points. Now, these 3 points, in this case, can be written in one of 2 ways. We've got angle CAB or angle BAC. What needs to be true about these 3 points is that the middle letter absolutely must be the vertex of the angle. So when you are labeling an angle using 3 letters, make sure that that middle point is the vertex. So you can call it angle CAB or BAC as if you were going to sketch that angle in one continuous motion in order. Okay. Any angle divides a plane into 2 different regions. We've got the region inside the angle. And remember, rays go on forever and ever and ever, so I can really highlight all out here. We've got this region, which creatively enough we call interior space. And any point in this interior space is called an interior point. All of the white space that you see is called the exterior space. And any point located on the outside of the angle itself is an exterior point. That's about it for the basics on angles. We've got different types of angles, and we use a protractor to measure angles. So here we've got a protractor, and I'm going to create an angle after I erase the highlighter. All right, I'm going to create an angle here, and I've got a 47-degree angle. I can move this anywhere between 0 and 90 degrees. An angle between 0 and 90 degrees is acute. If I've got exactly 90 degrees, one more over, 90 degrees, that is called a right angle, and this is the symbol that we use for a right angle. You use that hard angle there. Whenever you see that notation, you always know that a 90-degree angle is implied. Okay, we can also have obtuse angles. Obtuse angles are greater than 90 but less than 180. So we've got obtuse angles, obtuse meaning big, right? And then when you have a 180-degree angle, like so, 180 degrees, you know what this forms. This forms a line, and we call this a straight angle. So keep in mind, by the way, that this acute angle right here, I can orient it differently. Right? I can turn it upside down. The orientation is different, but know that it is still an acute angle despite the orientation. And when you're measuring angles, you might want to spin your paper around so that it's in a position that is easy for you to measure. All right, to recap, we've got 4 different types of angles. We've got an acute angle. Acute angles are angles measuring less than 90. So we've got between 0 degrees and 90 degrees. That's an acute. Okay, we've got right angles. Right angles measure exactly 90 degrees, and that's our symbol there. 90-degree angles are right. We have obtuse angles. Obtuse angles are greater than 90, but less than 180 degrees. That's a big angle right here, obtuse. And then we've got a straight angle, which measures exactly 180 degrees. Okay, the last thing that we're going to talk about are what's known as adjacent angles. Adjacent angles, we've got two angles. Only two angles can be adjacent, not 3, not 4, not 26, only 2. And we've got adjacent angles when 3 conditions are true. The first condition, you can think of adjacent as being next to, right? So the first condition that has to be true is that they share a vertex, two angles that share a vertex. So if we look below at this diagram right here, looking at angles 1 and 2, we see this vertex right here is common. It's the vertex of both angles 1 and angle 2. That is not enough to make them adjacent, however. The second condition that has to be true is that both angles must share a side. You know that sides of angles are rays. This angle, this side rather, that ray, is a side to angle 1, and it's also a side to angle 2. We have a third condition that must be true. This is the one that a lot of people forget about. The third condition is that the angles cannot share interior points. They cannot share interior space. So no common interior points. All right, this is what I mean by that. We've got angle 1, right? Here is my interior space of angle 1. This is my interior space of angle 2. They are not overlapping. There's no common interior points. They are not overlapping. They do share a vertex. They do share a side. 3 conditions are true, making angles 1 and angle 2 adjacent. If I come over here and look at a couple angles to the right, I'm going to, let's see, I'm going to put circles here, dots, to indicate the interior space of angle NVA. Notice I'm using 3 letters, making sure that that middle letter is the vertex. And then I'm going to consider angle EVA. I can look right now and see, hey, they have the same vertex. I don't even need a diagram for that. They actually also have the same side. And I don't need a diagram for that either, because I see VA, I see VA, and here's that shared side. The third condition, so it takes care of 1, it takes care of 2. That third condition is that they cannot overlap. The angles cannot overlap. They cannot share the same interior space. And if you look at EVA, angle EVA, I'm going to indicate the interior space here. You have overlapping points. There is a space where you have both green and blue marking. So that is not okay. These 2 angles are not adjacent. Okay, so we're going to put a mark down here, and you should make a note as to why they are not adjacent. Angles that are adjacent, we can say EVN, and angles NVA. These 2 angles are adjacent because they share the vertex, they share the side, and they have no overlapping space. All right, I think that takes care of the introduction to angles. So you have some bookwork, refer to your homework calendar, and we will take your questions and go over that tomorrow.